Hello and welcome back to some more Bitburners. So in the last video I showed you guys how the get requirement script works, how to create your strategy, how to calculate the delays, and also the maximum number of threads to perform our attacks. In today's video, I'm going to be showing you guys how to construct your fleets using the requirements that we just calculated. So if we go into this function here, basically the fleets function is responsible for allocating the ships for every single action within the sequence. How it starts is first we grab the allocation. So this get allocation function basically just returns the number of threads that we need to allocate for every action within our strategy. So basically how this get total threads work is that we go through every single server. We calculate the number of threads that it can support by comparing the amount of RAM that's free against the amount of RAM that our viruses needs to be able to run. And then we just add all of those threads together. And then the next thing we do is we grab the maximum number of threads from the list of requirements. And then we construct our initial object, which is the threads object representing the number of weaken, grow, and hack threads that we need to allocate. And then down here we do two checks. So the first check we do is we compare, I guess, the recommended number of threads that we need for the server against the total number of threads that we have on hand. If the total number of threads that we have on hand is much bigger than the required number of threads to attack our server, then we just use the recommended amount. Otherwise, we then just use our strategy to sort of just divide up our number of threads based off some sort of percentage or some sort of allocation. So we extract the sequence and then the allocation using from our strategy object. And then for every action within the sequence, we then calculate the number of threads to execute that action by multiplying the total number of threads that we have in hand by the allocation. And then after that, we then assign that value to where they need to go. So if it's the action's weaken, so W, then we assign it to num weaken. If it's a grow, then we assign it to num grow, num hack, etc. And then by the end of this, we then have, I guess, our recommended number of threads that we need to allocate for every single action based off how much resources that we have on hand. Moving on to the next line, basically after we retrieve all the number of grow, hack, and weaken threads, we then create this object called contract. And the reason why I created this object is so that it's very easy to just look up values whenever we're creating fleets to their, I guess, the action symbol. So W, num weaken, grow, G is num grow, etc. And then we pass in this contract to the ready fleets function. So basically this ready fleets function is responsible for creating the fleets for every single action within the sequence of our strategy. The first thing it does is we retrieve the delays from the requirements and also the sequence that needs to be executed from our strategy. And then after that, we then sort the ships from the largest memory to the lowest memory. And the reason for this is because it's going to allow us to allocate the server with the most RAM first, so that we can efficiently, I guess, allocate our resources rather than having to go through every single ship over and over again. And this is another way of doing comparators as well, so you don't need to have an if and else statement. You can just use a mathematical formula, and it basically does the same thing as what we did in a few videos ago. And then after this, we then create a ship lookup. And what this create ship lookup does is that we basically just convert our ships array into an object that maps the server name to the ship object itself. And the reason why I have this notation is because I wanted to create a clone so that when the ship objects are modified through our one of the functions that we're using on the ready fleets function, it doesn't affect the lookup. So the initial value is always remains the same. But by the end of this function, we then retrieve a dictionary that maps the server name to the ship object. And then we initialize the assigned ships. So assigned ships is just a dictionary that maps the server name to the RAM that's allocated. And then fleets is obviously just a list of fleets that represents, I guess, an action within our sequence. And then for every single action within our strategy sequence, we retrieve a whole bunch of values like the action symbol, delay, action, max threads, and whatnot. And then we retrieve the assigned ships. So how unassigned ships work is we first map all the ships to, I guess, the new free RAM value. So if it's assigned, then we just use the ship lookup to grab the initial free RAM, and then we take away the, I guess, the assigned RAM or assigned values to recalculate the free RAM. Otherwise, if it's not assigned, then we just return the ship as is, and then we filter out the ships that doesn't have enough memory to support the virus, or the ones that hasn't been assigned yet. Moving down here, so after retrieving all the unassigned ships, we then create the action fleet. So what this function does is it basically constructs an object that groups all the servers together to execute a single action within our strategy. So it initializes the, I guess, fleet object. So you could see here the action and then a ships array. And basically all the ships that's defined here is just going to be executing just this single action. We also maintain an internal dictionary for all the assigned ships mapped to their allocated RAM, just so that we can update the main assigned dictionary. And we also keep track of the number of allocated threads as well. Basically, how this algorithm works is that we go through every single ship that's available to us, and then if we've allocated enough, so allocated equals or more than the required amount, then we just break out of this loop because we don't have to allocate anymore. Otherwise, we calculate how much threads we need to allocate. So how this works is that we first grab the number of threads, so the maximum number of threads that our ship can support, and then we create a variable that just calculates the new allocated threads, and then we compare that new threads to the max threads, so that if it's bigger than that, then we want to make sure that we only allocate the ones that we need, so we just subtract the, I guess, the amount that's left over. Otherwise, we use the server to its entirety, so just use the maximum execution threads. And then we update the assigned dictionary, mapping them to the, I guess, the node to the allocated threads amount. And then we just push the fleet object, so the node, the number of allocated threads, and then the delay to the list of ships. And then we just increment the used threads so that in the next loop we now have, I guess, a record of the new allocated threads. But by the end of it, you basically just have, I guess, a list of servers that's going to execute that action, as well as a dictionary of all the assigned ships. After creating this action fleet, the next thing we do is we just update the main assigned ships dictionary just so that the values are up to date. And then after updating the main assigned ships object with the new values, then we just push the fleet to our list of fleets. So by the end of this, we then have, I guess, an array of fleets that's gonna execute every single action within the sequence of the strategy. Down here we have an additional line for get unassigned ships. And the reason for this is because get unassigned ships has a very special side effect. And that side effect involves modifying the original sorted ships array. To understand how, I guess, how it works, you have to understand, I guess, an advanced concept called memory reference. So just to explain in the simplest way that I can explain it, basically your computer has a whole bunch of memory slots, and whenever you create some sort of variable in JavaScript or any programming language, you're basically just assigning them some sort of address within the computer's memory that stores this information. How this algorithm works, this ready fleets function works, is that it works as a pass-by reference. What I mean by this is, so let's say that you have two people that's passing a ball around. So let's say that this person here is the main caller, so the main logic, and then this ball represents the original sorted ships array. Basically, whenever you pass something by reference, basically what you're doing is you're passing in the I guess representation of the original object. This guy, person A, gives this guy the original ball. So whenever this guy does anything to the original object, so let's say that this guy decides to write his name on the ball, when it returns, then the original caller has the modified version of the ball. So pass by reference is basically just passing in, I guess, a variable that allows functions to modify the original object. So going back to the memory reference example again, basically what we're passing in is the object that references the ships arrays, or at least a ship object within this memory reference. And then whenever we make modifications, like for example this ship.freeRAM, whenever we do this ship.freeRAM, well, what we're actually doing is that we're actually modifying the original ship object within the original ships array, and that one will allow us to dynamically update the free RAM whilst executing our functions. So I don't expect you guys to understand that straight away. It's something that's I guess an advanced concept in programming. It actually took me a while to sort of get the grasp of how memory references work and how pass by reference works. But if you guys want something to Google, probably look up how memory references work, and also the difference between the pass by reference and pass by value concepts. And if you understand those, you can basically manipulate your data within your programs a lot more efficiently. But anyway, but what this final get unassigned ships call does is that it just basically just updates the free RAM according to the new assigned ships value. And then as soon as I guess we recalculate the RAM usage, then we just return the list of fleets that executes our strategy. And then if we go back to the main loop, it then gets assigned to this variable here called fleets. So yeah, so that's about it. Hopefully that all made sense. I know that the concept of memory references and whatnot is probably a bit advanced for beginners, but it's definitely worth looking into if you wanna, I guess, step up your game in programming. Alright, so in the next video, I'm gonna be showing you guys how to use these fleets object to launch the attack, and then also recalculate the ships object so that we exclude the ones that doesn't have any memory to support the virus anymore. But I'll cover that in the next video. So I'll see you guys in the next one.